Hello viewers, my name is Henry Edem and this is Sethoo Edu TV. We are going to continue with the vectors from where we ended the last time, and we are going to continue with equal vectors. The last time we went through the converting a vector to magnitude bearing form. That is the last thing we did. We have also already gone through the we have gone through scalar of a vector. We have gone through the magnitude bearing form of a vector. And we have also gone through the Cartesian component form. Today we are going to continue with the equal vectors. That's what we are going to continue with, and then we move on from there. So, equal vectors. Equal vectors. Now, two vectors are said to be equal if and only if one vector, they are having the same values. Okay? So, for instance, if you have vector AB to be x, y, and then vector pq to be, let's say, x1, y1, and then vector pq to be x2, y2, then we can say that AB is equal to pq when their values are the same. So then AB is equal to pq when the value here and the value here are equal. The value here and the value here are also equal. We also have the magnitude bearing form of a vector when vector AB is having p units,
I'm working on it.
and then k degrees, let's say 0, 0, 0 or 000 degrees, then it means that for it to be equal to pq, that means this must also have p units and then 000 degrees. Okay, let's take an example and use that to explain further. Okay, let's take an example and use that to explain further. So let's take this. If A equals 1 plus x minus 3 plus y, and B, okay, that is vector A, vector B, is 2, 3. Find the values of x and y. Okay, now, like we have already explained from the 2 points I have given, this is equal to that, means that the values in here are equal to these values. All right, now let's look at the solution. With the explanation I gave from the equal vectors above, we realize that if AB has points, let's say 2, 3, let me use different things, let's say 7, 5, then if it is supposed to be equal to PQ, then it means that PQ should also have what? 7, 5 as coordinates. So that if they are telling us that A is equal to 1 plus x and minus 3 plus y. Then b also is 2, 3. Then we can say that if this and that are equal, according to the question, they said if a is equal to that and b equals that, we should find the values of x and y. They didn't tell us they are equal. But the only way we can find x and y is if this is equal to that. So we can say that a is equal to b implies that 1 plus x minus 3 plus y is equal to 2, 3. And then from here we can get two equations. We get the first equation from the x coordinates and then the second one from the y coordinates. So we say 1 plus x equals 2 as equation 1. Then minus 3 plus y equals 3 as equation 2. Now in this case, we don't have two different variables in each equation. We only have one variable each. So we can easily solve for x and y from the equations. There's no need solving it simultaneously. So we say that from equation 1, 1 plus x equals 2, and that implies x equals 2 minus 1. That implies x equals 1. And then from equation 2, we say that minus 3 plus y equals 3. And that implies y equals 3 plus 3. And we have y equals 6. Therefore, x equals 1 and y equals 6. As simple as that. So that is how equal vectors are dealt with. Alright, now let's take this question and see how we can go about it. Given that a is equal to x minus 3 and then y plus 1. And c is equal to 1, 2. Find the values. Find the values of x and y. If a is equal to c. Let's take another one. So there's 1, 2. Given that p equals that 2x minus 3 5y plus 4 and q equals 3 9, find the values of x and y. If P is equal to Q. Given that A equals x plus 5, 2y minus 8, and B equals 3 minus y, x minus 3y, comma, find the values of x and y if A is equal to B. If A equals half x minus 3 and 3y minus 1, and B is equal to 4, 8, find the values of x and y if A equals B. Let's add the last question. I'm going to solve a few of them and I'll leave the rest to you to solve. Find the values of x and y in the equation Okay. Now, looking at these questions, you realize that they're supposed to be question 5, not 2. Looking at these questions, you realize that it is the last one that is automatically straightforward question. All right, you don't need to think much to be able to do this one, because automatically when you see this, you know you are supposed to get 2 equations and then solve them. But then the other ones, it is the idea of equal vectors you are supposed to use. Realize that this one you've been told that A is equal to C. That is to say, vector A is equal to vector C. So you equate this to that and then solve. The same thing applies to this, all right? They said vector p is equal to vector kill. So you equate p to kill and then solve. The same thing applies to question 3. They said vector a is equal to vector p. And then question 4 also, vector a equals vector b. All right, so that is it. Now let's solve 2 questions out of the lot, and the rest you do it by yourselves. So I'm going to solve question 3 and 4. Okay, 2 and 4. Yeah, I think 2 and 4 is okay. So I'm going to look at question 2 and then question 4. So question 2, we have p, that is vector p, to be equal to 2x minus 3 and then 5y plus 4. All right. We also have vector kill to be 3, 9. And they're asking us to find the value of p and kill. Sorry, the values of x and y. If p is equal to what? Kill. So p equals kill implies that 2x minus 3, 5y plus 4 is equal to 3. Now 2x minus 3 equals 3, 5y plus 4 equals what? Kill. So we say that 2x minus 3 equals 3 becomes equation 1. And then 5y plus 4 equals 9 becomes equation 2. Once again, there's no need solving this simultaneously because you can easily get x from equation 1 and get y from equation 2. So we say that from equation 1, we have 2x minus 3 equals 3. Then we have 2x equals 3 plus 3. We have 2x equals 6. Divide that by 2, that by 2. And then my x is equal to 3. Let me just bring it here. And then from equation 2, we have 5y plus 4 equals 9. And then 5y equals 9 minus 4. 5y equals 5. Y is equal to 1. Therefore, x equals 3 and y equals 1. So I said I'll be solving question 2 and 4. So I'm moving on to question 4. Alright, so question 4. Question 4 says a is equal to half x minus 3. And then 3y minus 1. And then b is equal to 4, 8. Alright, and we have been told that a is equal to b, and we have to find x and y. So we say that vector a is equal to vector b, and that implies 1 over 2x minus 3, 3y minus 1 is equal to 4, 8. And then we can we can say that 1 over 2x minus 3 is equal to 4 becomes equation 1. And then 3y minus 1 equals 8, and that is equation 2. So from equation 1, 1 over 2x minus 3 equals 4 becomes 1 over 2x equals 4 plus 3, and then 1 over 2x equals 7, and then we cross multiply. This multiplies that, that multiplies that, and x is equal to 14. From equation 2, we say that 3y minus 1 equals 8, and that implies 3y equals 8 plus 1. 3y equals 9. Divide this by 3, that by 3, and then y is equal to 3. Therefore, x equals 14 and y equals 3. Alright, so you solve the rest of the questions by yourselves. You have question 1, 3, and 5 to do by yourselves. Okay, so that brings us to the end of equal vectors. Let's move on to parallel vectors. Let's move on to parallel vectors. Let's move on to parallel vectors. Alright. Now, two vectors are said to be parallel if and only if one is a scalar multiple of the other, or both of their gradients are the same. So, for instance, if vector pq has x, y as coordinates, or as its vectors, its vector, and then uv has x1, x2, y2. So let's make this x1, y1. Then pq is said to be parallel to uv, and that is how mathematically it's written, all right, with those two lines in between them. So pq is said to be parallel to uv if the gradient, okay, the gradient of pq is the same as the gradient of uv. So gradient of pq is equal to gradient of uv. Okay, in other words, you can say that if pq is equal to a scalar product of, or a scalar multiple of uv, are you okay? And it's as simple as that. It's a very simple scenario, very simple process, very simple method. Let's take a few examples and then we are good to go. We move on to perpendicular vectors and then we can now solve some questions. After which we look at the triangle law of vectors, look at the parallelogram law of vectors, and then we are done with vectors. Just take some few examples and that's it. So let's take some examples of parallel vectors. Some examples of parallel vectors. Okay, so let's look at these questions. And I'm sure we are okay with them. Alright. If the vector m10 is parallel to 25, find the value of m. That's the second one. The first one is which of the following is parallel to minus 4, 3? And you have possible answers there. So you check each of them and see which one is best. Alright. Now let's take the last one. I'm going to solve just one, solve the rest. Okay, so let's solve, I'll solve the third one, do the first and the second one on your own. You do first and second one, you do the third one. If the vector 7, 4 is parallel to 14 and then 3x minus 1, find the value of x, right? And then we have the vector 7, 4, which is parallel to 14 and then 3x minus 1. So if this is parallel to that, then it means that the gradient of this should be equal to the gradient of that. Alright, the gradient of this should be equal to the gradient of that. Or this should be what? A scalar multiple of that. Okay, and you can see that 7, in the first one we have 7 as the x coordinate, and then the second one we have 14 as the what? As the x coordinate. So it means that we multiplied 2 by the first one to get the second one. Okay, so you can easily say that twice of this is equal to that. Okay, or you can also use the gradient approach. Using the gradient approach, it is this way. We say 3x minus 1 over 14 is equal to 4 over 7. When we cross multiply, we have 7 into bracket 3x minus 1 is equal to 4 and then 14. That gives us 21x minus 7 equals 56. Then this becomes 21x equals 56 plus 7. So you have 21x equals 63. Divide this by 21, divide that by 21, and then x is equal to, this goes there 3 times. So we have x to be equal to 3. It's as simple as that. You can as well use this approach. Like I said, one of them should be the scalar multiple of the other. So instead of using the gradient approach, you can as well use this. Like I started explaining, you realize that it was 7 here, but over here it is what? 14. It means that 2 times this gave us that. So if that is the case, we can say that 2 times 4 is equal to 3x minus 1. And then 2 times 4 is 8. That is equal to 3x minus 1. We want x, so we move the negative 1 to the other side. We have 8 plus 1 equals 3x. We have 9 equals 3x. Divide both sides by 3. And then we have x to be equal to 3. You realize we will always have the same answer. Okay, so that's it. You solve the other 2 on your own. Let's move on to perpendicular vectors. Perpendicular vectors. With perpendicular vectors, we say that one vector or the gradient of one is equal to the negative reciprocal of the other. All right, the gradient of one is equal to the negative reciprocal of the other vector. Or you can also say that for two vectors to be perpendicular, it means that one of them is, or we can say they are a scalar dot product of each other. Okay, or you can say that the scalar dot product of them is equal to what? 0. This is what it means. If we have vector pq, use this one too much. Let's say vector xy to be equal to x1 y1, and then vector cd is equal to x2 y2. What we are talking about scalar dot product, this is how it is done. Talking about x1 times x2, all right, and then plus y1 times y2, and this should be equal to what? 0. Okay, so the scalar dot product should be equal to 0. All right, so with that understood, let's take an example. Okay, let's take this question. If AB is equal to minus 2, 3, and PQ is equal to 3, 2. Determine whether AB and PQ are perpendicular vectors. Determine whether AB and PQ are perpendicular Okay, so like I explained, for them to be perpendicular, it means that one of them, or their dot product, should be equal to what? 0. Okay, their dot product should be equal to 0. So let's go through this. Okay, so let's go through this quickly, and then I'll give you some 2 or 3 more to do by yourselves. AB is equal to minus 2, 3, and then PQ is equal to 3, 2. Now AB dot PQ should be equal to 0 for it to be what? Perpendicular vectors. All right, and then I said the dot product is this: minus 2, that is the x in AB times the x in PQ. Okay, and then plus the y in AB, and then times the y in PQ. So it is minus 2 times 3, and then plus 3 times 2, and that should be equal to 0. If it is not equal to 0, then they are not perpendicular vectors. Now minus 2 times 3 is minus 6, then 3 times 2 is 6, and truly it is what? 0. Therefore, the vectors AB and PQ are perpendicular. Perpendicular. Okay, so try these two questions on your own. Remember that I mentioned the fact that two vectors are also said to be perpendicular if their products, if the gradient of one is or if the product of their gradient is equal to -1, or the gradient of one is negative reciprocal of the other. So I'm going to write that down for you here so that you remember that. Okay, so the okay, so these are the questions I've given. Try solving them. The first one is uv equals 10 minus 5 and xy equals 2 for determine whether uv and xy are perpendicular vectors. If AB is equal to 1, 3 and BC equals to 1, determine whether AB and BC are perpendicular vectors. That is the second. And with the third one, which of the following vectors is perpendicular to -1 and -1, 3? You have A, 1, 3, B, -1, -3, C, 1, -3, and D, -3, -1. Now, to solve the third one, it will be easier if you take into consideration what I have written down there. And it is the fact that two vectors are said to be perpendicular if the product of their gradient is equal to -1. All right, let's move on to the triangle law of vectors. Let's move on to the triangle law of vectors. Okay, so let me explain this to your understanding. Considering this triangle, we realize that there's a movement from A to B and a movement from B to C. And there's also movement from A to C. This diagram simply shows that the movement from A to B and then continuation of B to C is the same as the movement from A to C, as I have explained in the written explanation I have there. All right. Now, if that is the case, then it means that if AB denoted as vector A like that, and then BC is denoted as vector, let me not bring it here, let me just explain in vacuum. I'll give a typical example. Now with this one, you realize that if you have been given A, vector A to be xy,